Hello everyone. Today we are going to discuss about topological sorting. This topological sorting, we can perform this topological sorting with directed acyclic graph. So here the topological sorting of vertices of a DAG, that is directed acyclic graph, is an ordering of the vertices V1, V2, Vn in such a way that if there is an edge directed towards vertex Vj from vertex Vi, then Vi comes before Vj, which means we are going to perform this topological sorting with the help of a directed acyclic graph. We can perform topological sorting with directed cyclic graph, but the ordering will not be a perfect one. So that we prefer only directed acyclic graph. So in that, just consider here V1, V2 are two nodes. If there is an edge exists between V1 and V2, we say V1 comes first and V2 comes second. This way we can order the vertices of the graph using topological sorting. So this is mainly this is used to say which action will be performed first and which will be performed second and third and so on. So for those type of application, we can perform this topological sorting. So here the technique, or we say the strategy used, is identify a node with no incoming edge. So first we have to find a vertex with no incoming edge. Incoming edge will be 0 and add that node to the ordering. Then remove it from that graph, which means the incoming node, the node which is having 0 incoming edges, we are removing that from the graph. And we are going to repeat this process till all the nodes are processed. We'll see with an example. So this is the graph given. We are going to perform a topological sorting for this graph. So here A, B, C, D and E are the vertices given. So as a first step, we have to identify the in degree of each node. Okay, we have to calculate the in degree for each node, that is each vertices of this graph. So here in degree means the incoming edges. Just see this A is having how many incoming edges? How many incoming edges? Something like this. How many incoming edges? Nothing. So here no incoming edges present. Okay. So this is so here we say the in degree of A is 0. So likewise for B, C, D and E we have to calculate. Then what about the in degree of B? How many edges, how many links are getting inside? 1 and only 1. Okay, only one edge. So incoming edge of B is 1. And what about D? 1. So 1 edge and here 2. So 2. Okay. And what about E? Only 1. And what about, 2. 1 plus 1, 2. E. What about C? 1, 2. So for C it is 2 edges. So like this we have to we have to calculate the in degree of each vertices. Okay, so as a first step we have to calculate the in degree of each vertices. So once again I will repeat what is topological sorting. So here we are going to order the vertex. So in case you are going to order any process, which process should come first, which process should come second, we can perform this topological sorting or topological ordering in a given graph. So here as a first step we need to identify the in degree of each node. Okay, so likewise we have calculated the in degrees of A, B, C, D and E, and we have represented the in degrees also. So this is the first step of the topological sorting, and we can perform this topological sorting with the help of directed acyclic graph. Okay. We'll see the next step in the next video.